If you're an engineering student, come closer. Let me teach you how I designed this circuit diagram for a smart solar home power system. Yes, smart solar. You might be wondering why it's called smart. Yes, it is smart because this is the purpose of this project is to run as a smart device in your house or your office, anywhere you want to put it. So here I am using Pro Tools 8.13 version to design this, and here I am picking my components. As you can see, these are all the components I'll be needing, so I have to pick them first before I dwell into the drawing. Let's start from the input, the solar panel, which is the primary input of the system. It is from this solar panel we take our wire to the charge controller, and in this circuit we are using MPPT charge controller. Now it has been connected to the MPPT charge controller. I could not find the library for MPPT charge controller, so I just drew out one and labeled it myself. It has been connected to the BMS, or from the BMS to the battery. So here we are having a buck converter. This buck converter will be connected to the ESP32 to serve as a power supply for the ESP32 because of the maximum voltage that can be supplied to ESP32. So we need a buck converter to just avoid damage. Now here is another buck converter. This buck converter will just be working as a supply, a backup power for the charging modules. So once the battery is running low and is at 20% already, ESP32 should trip off the main supply to the charging module, and then the charging module can run on the backup plan we have for it already. So here we have 5 switches here already, 5 buttons. This is just to switch on each relay that we have here manually, so meaning that the ESP32 cannot just switch on the relay without receiving a command manually. Here it's just to tell you that we can run the system manually. We can also run it from our mobile device. Yes, it can run from your mobile device because this is designed to work wirelessly, so you don't have to be there before you run the whole system. Here we have the 3 current sensors. These current sensors are monitoring the currents coming from the charge controller, the current coming from the battery, and also the load current. Now on the OLED screen that we have here will be the display for the amount of voltage coming in, the amount of current drawn by each, and then to tell us the status of each load output. We have 3 LEDs up here as an indicator for the status of the system, the battery charging, and also to let us know what part of it is working. Now we have our current sensors connected here to each various outputs we want to measure our current from. We've connected the relay. Please mind you should be careful of how you connect relays on your circuit. Be very careful, most especially the diode connection, the transistor connection, and then the value of resistor that you'll be using. I'm using a 4.7 kilo ohm resistor here, and I'm using a transistor, NPN transistor of 2N222A. In this diagram here, I'm using the normal Zener diode. Fine. So the loads that we have here, we have 3 12 volt DC lamp and also a DC fan. This is just the schematic diagram for each component. So all has been connected together, and then we have our full diagram here, a smart solar power system. Here is the final diagram with a well labeled component. Thanks for watching with me.